Okay, this is chemical nomenclature, which means naming chemical compounds. But we're going to be using polyatomic ions. So polyatomic ions, just to give you some examples, we have a list of some common ones. Ammonium is NH4 plus 1. That's ammonium. So anytime you see a word that doesn't end in IDE, it's probably not on the periodic table. It's a cluster, it's a group, okay? They act together. So if you see OH minus, that's hydroxide. That's a polyatomic ion. All right, if you, I'm just looking at taking a little random assortment. If you look at ClO3, chlorate, ClO3, that's chlorate, -1, that's the charge. All right, those are examples of polyatomic ions. So if it ends in ATE, it's not going to be chlorine, it's going to be something else, right? So in this case, it'll be a little group of elements that act collectively together, and they carry their own charge. All right, if you remember, we said if it's a metal to a non-metal, it's type 1 nomenclature, right? So today we're just going to focus only again on type 1, but this time it's using polyatomic ions. So your directions will be one of two things. You'll either be asked to write the name of or write the formula for. Okay, and that'll be it. So your next test, that's all the directions would say. Write either the formula for or the name of, and you'll be given either the compound formula or the entire name and be asked to write the formula. All right, let's start by doing, let's do the write the formula first, okay? All right, if we had calcium hydroxide, all right, calcium hydroxide. We said the first step is to write each symbol, then write the charge for each symbol, and crisscross the charge number, and simplify whenever needed, all right? So we know calcium is Ca, and it's in group 2, so it's +2, all right? Hydroxide is not on the periodic table by itself, right? It sounds like it may be a polyatomic ion. If it were hydride, that would just be hydrogen. But hydroxide has its own formula, right? And you got to find which formula matches up with hydroxide. So hydroxide is OH minus. OH minus. So write OH minus. All right. Now the last step is to crisscross the charge, and then you simplify if necessary. All right, when you drop these numbers down, all right, that's understood to be a -1, right? I don't have to write a 1 because it's understood. I see that there's 1 calcium, all right? That 2 has to apply to the whole hydroxide ion. And you know this from math class. Anytime a letter or a number is supposed to apply to more than one thing, you have to put that thing in parentheses, right? So this is the main difference for type 1 when you're using polyatomic ions. You've got to put parentheses around the OH and then drop the 2 down. So it's calcium hydroxide is CaOH2. So the big thing is to always put parentheses, all right? And this again gets easier and easier the more of these that you do, all right? So let's do another one, and let's say it were to be, let's say it's going to be calcium carbonate. Calcium carbonate, all right? Well, carbonate, we know that's not something that you're going to look up on a periodic table. It doesn't end in IDE for one thing, so it must be a polyatomic ion. All right, but the rule is just like it always is for type 1. You write the symbol, write the charge. Carbonate is CO3 -2. You can say 2 negative or -2, either way. All right, and how did I know that? Because it's on the list that I have of polyatomic ions, common polyatomic ions. All right, when I crisscross the 2, that 2 is going to drop down here and apply to the calcium, but this 2 must apply to that whole thing. Don't ever take that apart or do anything with it. To bicarbonate, it has to remain CO3. Okay, you might have 2 of them, but you don't change that exponent ever. All right, or subscript. Don't ever change that subscript. So when the calcium, its charge drops down here, you would think it would be 2 on 2, right? But we have to do what? The final step is simplify if needed, right? 2 goes into 2 one time. So it's like they cancel their 1-on-1 ratio. All right, so it's just CaCO3. Now, a lot of times students will say, well, would it be wrong if I forget to simplify? You're not going to see, you're on a bottle of calcium carbonate, it's never going to be written that way. You're going to see it in its simplest form. So CaCO3, you just have to remember to simplify. All right, so let's do another one. And again, these get easier and easier with practice. All right, let's do one that we've used a lot. Sodium hydroxide. We use that in lab quite a bit. All right. Well, I know hydroxide is not hydride, so it's not just an H. It's got to be a polyatomic ion. So I'm going to do the symbol. Hydroxide is OH minus 1. All right. And remember, if it's 1-on-1, you don't need to write a 1. They're understood, right? So when I crisscross this time, this charge, all right, it's just NaOH. So initially, it would be this, but we don't write 1s. They're understood, so we can cancel that. We don't even need the parentheses. So that's sodium hydroxide, the formula for sodium hydroxide. All right. All right. What if we had, you could have one that has a polyatomic ion that's positive and a polyatomic ion that's negative. So let's do one like that. If I had ammonium sulfate. All right, well, ammonium that's not an element. It's not on the periodic table, so it must be one of our polyatomic ions. It's a group of elements that act collectively together, right? And they have their own overall charge. Ammonium's formula is NH4 plus 1. Sulfate. Sulfate, if it doesn't end in IDE, we know it's not on the periodic table. It must be a polyatomic ion. So what's the formula for sulfate? If you look it up, it's SO4 negative 2. When I crisscross just the number, not the charge, not the sign, right? It's going to be NH4, and that 2 has to apply to the whole thing. So we have to put parentheses around it. And then we don't need to write a 1 because it's understood, so it's just SO4. So that looks a little different than what you might be used to seeing, but it's correct. So just remember, if the or the charge number has to apply to more than one element, you have to put parentheses around that element or elements. All right, so let's do another one similar to this one. What if you had ammonium hydroxide? Ammonium hydroxide. All right, well, ammonium is not on the periodic table. I don't know of any element that's name is ammonium, right? So it must be a polyatomic ion. So it's NH4 plus 1. Hydroxide is OH minus 1. And the more times you use this, you start memorizing them just because of repetition, right? Hydroxide, we use hydroxide a lot, especially in the lab. Sodium hydroxide, potassium hydroxide, calcium hydroxide. All right, if it's going to be a 1-on-1, I don't need to write 1s, they're understood, right? I could drop it down and say NH4, 1, OH, 1, all right? But it's just simply NH4OH. If it's 1 on 1, you don't need to write a 1 because 1s are understood, all right? So that's how you do the formula. If you're given the name and you're asked to write the formula, you write the symbols like we always did, right? You write the charges and then you crisscross and simplify if necessary. Just remember this time when you drop the charge down, you've got to put parentheses around the if it's a polyatomic ion, you have to put parentheses around it. All right. The other set of directions is even simpler. If you're told to write the name, all you have to do is just say the name. All right. So if you're told write the name of, write the name of. All right. And let's say I had AlOH3. I don't even really have to worry about what ratio they're in or the subscripts or whatever. All I gotta do is look at the name. Al is aluminum. So you just say the name, aluminum. And then OH is not, it's a polyatomic ion. It's many elements acting collectively, right? So it's not on a periodic table, it's one of your polyatomic ions. So OH is called hydroxide. And that's all you do. You just name it. Say the name. Aluminum hydroxide. All right. What if we had MgCO3. MgCO3. All right. Again, you would just say the name. Mg is magnesium. And in CO3, it's not one single element. It's a polyatomic ion. So you look at your list and find it. It's called carbonate. So this one's called magnesium carbonate. All right, and that's all you do. That's for type 1 nomenclature using polyatomic ions. So the rule's the same as when we did type 1 metal to non-metal, except this time it involves groups of elements that act collectively and they have their own charge. And that's chemical nomenclature, type 1 metal to non-metal, using polyatomic ions.